Alrighty, let's work on problem number 4 now. Eliminate the parameter in the given parametric equation and write the equation of the given conic section in rectangular form. But let's go farther than just rectangular form. Let's go ahead and factor it and make it look like a parabola, because then we can easily find the vertex, focus, directrix, the length of the lattice rectum, and sketch it. So let's get started. How do we eliminate a parameter? Well, we need to solve for something that we can plug into the other equation. Now don't let this y of t, x of t stuff confuse you. Just think of it as y, just think of it as x. We're just saying that x is a function of t and y also is a function of t. You should be able to look at this and see that we are in fact dealing with a parabola, since one of our set of parametric equations gives us a squared parameter and the other does not. One linear, one squared, therefore we have a parameter. So let's think about how this is going to work. The easiest equation up here to solve for the parameter is y, because it's basic. It's just t plus 1. Whereas in x, we have a square root and it's kind of ugly and nasty, so we don't want to deal with that. So let's solve this equation for t by subtracting the 1. What do we get? Well, we get t equals y minus 1, which is an expression we will take and we will plug it in to our x equation right there. So notice the y term will be squared, which means we will end up with a horizontally opening parabola. Because think about, normally we like parabolas that look like this, y equals x squared. That's our old friend. So you can remember it that way. Y is squared, which is weird, so it's horizontal. Okay, so let's write our equation. X equals negative 1/4. Instead of t, we are writing y minus 1 and squaring it because t is squared, plus 3. Now at this point you might be tempted to expand that y minus 1, FOIL it out if you will, but that would be a waste of your time because we are simply trying to get this into our familiar conic form because that's what is useful to us. So how do we do that? Well, I need to certainly get rid of this plus 3 by subtracting it over to the other side, and so I have x minus 3 equals negative 1/4 times my expression y minus 1 squared. So again, what's the next step that I should take? I'm going to think of that in parentheses because I am about to then take this negative 1/4 and multiply that on both sides to get a I was about to say positive. I meant to say, to move that over, I'm multiplying by 4, negative 4, which means that I'm going to end up with a negative 4 coefficient out in front of that x minus 3 equal to my y minus 1 expression squared, right? Because I multiplied by negative 4 on both sides. That gets rid of the denominator of 4 and it gets rid of the negative, so that my expression on the right has nothing in front of it, which is how we want it. We want the squared piece to be alone, and we want the other side to be factored with just a coefficient out front. Make sure the x on the inside is positive. That way we know now that p is negative something. How do we know? Well, all we know is that 4p is negative 4, which implies then that p equals negative 1. Divide both sides by 4, you get p equals negative 1. That's useful because p tells us the distance from our vertex to our focus. So let's look at what we have. We have a vertex at positive 3, 1. How do I know that? Well, again, it's factored. Just like an ellipse is factored, we can identify the center. Just like a hyperbola is factored, we can identify the center. Well, when a parabola gets factored, we can identify its vertex, because it doesn't have a center, because it goes on forever. But it does have a vertex, which is kind of in the middle in a way. I don't know. But there you have that. So from that vertex, and from the fact that we know that this parabola is horizontal, we know the y value of the vertex will be the same as the y value of the focus, which means I know it will have a y value of 1 and the vertex is what will be changing. Well, if you have your vertex, you can find your focus because it is going to be your vertex plus your p-value. So 3 plus a -1 gives me 2, because it's really like 3 minus 1. So 2, comma, the y-value stays the same at 1. Now, if I go that p-value in the other direction, you get your directrix equation, which, how are we going to find that? Well, again, you got to think about your parabola. It is horizontal, which means it's running sideways, which means the axis of symmetry is horizontal, which means the directrix is vertical, because they will always be perpendicular. How do you write the equation of a vertical line? You say x equals some number. Well, what number is it? Well, it's the number that is coming from the x value of our vertex, 3, but p away in the opposite direction of the focus. So instead of subtracting 1 like we did to get to our focus, we need to add 1 to get to 4, and so x equals 4 is the equation of our directrix. What else do we want to do? We eliminated the parameter. We got it in rectangular form. We found the vertex, focus, directrix. Oh, the length of the lattice rectum is always in the form of 4p, but it is a length, so you should think of it as the absolute value of that. Well, what is 4p? Absolute value? Well, that's positive 4. It's just that coefficient right there, positive version of it. So I'm going to say the lattice rectum equals 4. Alrighty, anything else we need to do? Sketch the graph, show everything. How about we move this over so that we can more easily see it? Or let's just do this. I'm going to copy this equation, boop, boop, and I'm going to use that to graph it. So now let's go over here. Let's take a look at this equation and think about how we're going to use it. First off, again, I need to draw myself some axes. Well, where do I know the center is, and which way do I know it's opening? Well, I know the center is at 3, 1, and I know it is opening to the left because that p-value is negative. So it's opening to the negative direction, and it is a horizontal parabola, so to the left versus down. So all I'm going to do is draw in some axes here, right like that. X value is 3, 1, 2, 3, right there. Y value is 1, so right there. So boom, there's my vertex, which means my focus is boom, right there, 1 away, which means my directrix is boom, running vertical right there, which means my parabola is going to look like that. Now notice I'm not plotting those points precisely. I could, but I'm really not in the mood, so I think we're going to call this good enough.